David Smith here with another Flipped Classroom math lesson. 3 tips before we start. Remember that you can adjust the playback speed if that helps you work through the video. You can also pause the video at any point to take notes or jot down questions. Lastly, you can turn on the captions so you can read my words go by on the screen. Today's lesson talks about quadratics in the context of expanded or general form, and then we're going to finish up with a look at what we call factored form. So we're going to end up with 3 forms that we can talk about quadratic equations. Vertex, which is what we did last, expanded, which is general, or else factored. And each of those forms have their pluses and minuses. And just to know, by the end of this unit, you're going to be expected to be able to go from one form to another pretty quickly and easily. Let's get started. So here is a quadratic in vertex form. And we know our vertex is -1, -4. Our a term is 2. So this one is a little bit compressed or narrower. A is positive, so it opens up. And we can quickly make a graph based on that. But this time, what we're going to do is expand this, which means turn it into general form. Now, if you recall, expand means do all of your multiplications. Factoring is the opposite of expansion, and we'll get to that in a little bit. So when I expand this quadratic, I'm going to walk you through the steps this time, but in future ones, I'm going to go much quicker because this is expected that this is prior knowledge from your last math class. So remember, we have our exponent here. We have to do this first. So what we have here is a little perfect square, x plus 1 times x plus 1. So what that's going to give us, I'm going to bring down my 2. It's going to be x squared plus 2x plus 1, close my parens, and then I have my -4 out there. Now, if you remember your general form, you know we're not there yet. I'm going to have to distribute my 2 on each term inside my parens next. So I get 2x squared plus 4x plus 2 minus 4. And I'll finish that up by going 2x squared plus 4x minus 2. Now that is our expanded form of this quadratic. All right, now when we look at this, this is not like vertex form. I cannot tell what the vertex might look like in this quadratic. I have a sense that it opens up because I don't have a negative on my x squared. And I might have a sense that it's going to be compressed or a little bit more narrow because this is 2. It's bigger than 1. But I don't really have a good sense of what's going on with this quadratic. Fortunately, we have a couple little formulas that will help us do that. For the axis of symmetry over here, this is the formula for the axis of symmetry. So we just do minus b over 2a. And you'll recall that this is ax squared plus bx plus c. And our a and our b and our c are these coefficients of those terms. So minus b over 2a, let's just bring that forward. Our b is 4, so we do -4 over 2 times our a term, which is 2. So that would be -4 over 2 times 2, and that's going to be -1. So our axis of symmetry is x equals -1. So, cool. We got the axis of symmetry out of our general form quadratic equation. Now, think about the vertex. Think about the y-coordinate of the vertex. How do you get that? You know, right here you have enough information to quickly get that. Okay, so here's the thing. The vertex is given by -b over 2a. Remember, the x-coordinate of the vertex is on the axis of symmetry. So that's the x-coordinate of the vertex. Then what we do is we take that x-coordinate and we run it through the function to get the y-coordinate. So the y-coordinate is going to be f of -b over 2a. So this is your recipe for getting the vertex out of a quadratic equation in general form. So let's finish that. What is f of -1? F of -1, just going to go do our plug-in step. It's going to be 2 times -1 squared plus 4 times -1 minus 2. Go ahead, if you haven't paused the video yet and solved that, crunch that all the way through, come back. All right, let's see how you did. I just crunched my numbers, distilled it down. I got -4, so my vertex is -1, -4. Now let's go all the way back to the start. We were in vertex form, and guess what? Our vertex is -1, -4. All right, I want you to try this one. Here's a quadratic in vertex form. I want you to first convert that to general form. Go ahead and expand the quadratic, and then use general form to find the axis of symmetry and the vertex. I've left that stuff up there, but you also have this in your notes. So go ahead and pause the video and work that problem all the way through, and then come back and see how you did. All right, let's see how you did. I expanded my binomial, my perfect square. I got this in there. Then I multiplied every term in there by my 3 and combined it with the plus 3 out there, and I get this general form quadratic. So that's the answer to part 1, convert it to general form. Now, finding the axis of symmetry, I just do x equals minus b, there's my b, so it's minus 12 over twice a. A is 3, so 2 times 3. This ends up being 2. So the axis of symmetry is x equals 2. Now, to find the vertex, I just take the x-coordinate of the axis of symmetry and put that into the function here and solve that down, and I get 3, so my vertex is the point 2, 3. Cycling all the way back around, I got that right. My vertex is 2, 3. So that's kind of a confirmation step that that indeed worked. All right, now the y-intercept is super easy from general form. So first we're going to find it mathematically, but once we do that, we're going to see that there's a super quick shortcut for that. So here we go. Finding the y-intercept from general form. Here's an example. We've got f of x equals 6x squared minus 17x plus 4. Those coefficients are kind of wonky. It's going to be interesting to find all the various forms. We're probably going to have fractions and things, and it might be ugly. But really all I'm going to ask you for this one is just to find the y-intercept. So there's a critical thinking step here that once you do that, then you know the math to do. So think about what happens with the graph when it crosses the y-axis. There's a certain thing that goes on that allows you to do some math on here to find the y value. Okay, when the graph crosses the y-axis, the x value is 0. So, and we know that because the coordinate points for a y-intercept are 0 something. So the x value is 0. So all we have to do is do f of 0, and then we'll find our y-intercept. Now when you see this, you're going to realize what's going on here. The terms with x's in them go to 0. So the y-intercept is the point, in this case, 0, 4. All right, a quick summary of what we can get from general form. Ax squared plus bx plus c, there's our general form. Symmetry axis, minus b over 2a. Vertex, minus b over 2a, and f of minus b over 2a. And lastly, the y-intercept is just 0c, or the last term, the constant term. Now, there's one thing that we can't get easily. What might that be? Pause the video and think about that for a sec. Okay, what about the x-intercepts? Those we cannot get easily from this form. However, that's what we're going to do when we finish up this video, so just stay tuned. All right, here comes a third form for quadratic equations. And if you had me in math last year, this form we did not use when we did our graphing of our parabolas, so this will be new to you. So check this out. It's called factorized form in your book. I call it factored form. Factorized is a little bit longer of a word. Doesn't matter, they're the same. So factorized form. Here's one of the benefits. It shows you the x-intercepts, and they are as easy to get as the y-intercepts are from general form. So check this out. Here is factorized form, okay? A few more letters going on, but it's all doable. So here's our good old trusty a, same a. We know this, we know what it does. Now we have x minus p in parens times x minus q in parens. So new letters, and what those are the intercepts. So the x-intercepts are p0 and q0. Pull them right out of the equation. It's right there in front of you. Notice how the minus does not come with it. So if this was x minus 4, then the intercept would be 4, 0. Alternatively, if this was x plus 6, then the intercept would be minus 6, 0. And that comes from when we solve each of these binomials. If you remember solving quadratics, you'll see why the sign changes for the letter when you determine the intercept, which is a solution to the equation when it's set equal to 0. So we could also get the symmetry axis and the vertex in a fairly similar way as to general form. So the symmetry axis is just P plus Q divided by 2. And we'll show that in a minute when we get to the graph, why that's the case. And then the vertex is just P plus Q over 2. That's the x-coordinate of the axis of symmetry. And then you run that value through the function, f of P plus Q over 2, to get the y value, and that will give you your vertex. All right, let's put that last board to use. So here is one of these things in factorized form, x minus 2 times x minus 4 times x minus 2. And if you're thinking, oh, this doesn't look like a quadratic, where's the squared? If you expand this with your trusty old FOIL technique, you're going to get a quadratic looking equation in general form. We're not going that way. So here's the command. Find the x-intercepts, the symmetry axis, the vertex, then draw a graph. And without your graphing display calculator. Part of the reason we have all of these fancy forms that give you information is so that you can make graphs by hand. And you should be ready to do that. So pause the video, use your notes from the last board, and do these things, and then come back. All right, let's see how you did. So for my x-intercepts, I just pulled my numbers out of the form and changed the sign. So minus 2 becomes 4, 0. I'm sorry, minus 4 becomes 4, 0. Minus 2 becomes 2, 0. Done. Second thing, symmetry axis. It's just going to be x equals the 2 intercepts divided by 2, which is 3. And we'll look at that in the graph in a minute and talk about why it is the average of the 2 intercepts. Finally, the vertex is just going to be the symmetry axis run through the function, which gives me minus 1. Hence, my vertex is 3, negative 1. Over to the graph. I plotted my vertex. I plotted my two x-intercepts. I didn't dash in my symmetry axis, so let's do that. X equals 3. And drew my graph. Now, if you're noticing something, I labeled the y-intercept. And it was really easy to get that. This is not something the book is going to ask you to do right away, but it's something you should know how to do, and it's just a quick critical thinking step to realize how I got that quickly. So take a look at our function here. How might I get that intercept really fast? Check it out. The y-intercept happens when x equals 0. So I'm just going to add this right here, y-intercept, and I do f of 0 equals 0 minus 4 times 0 minus 2. That's going to give us minus 4 times minus 2, which is positive 8. So this is going to give me 8. So the y-intercept is the point 0, 8. So that was nice and quick. So this form actually provides you access to everything you need to draw your parabola. Alrighty. Here is your last example, and thanks for hanging in. I know this video has been a little bit on the longer side, but just stick with me. This is the last example. I'll wrap it up after we get done with that one. So here's your factored form, your factorized form. Here's your instruction. Find the x and y intercepts, so use that little trick I just showed you, symmetry axis and vertex, and then graph without your graphing display calculator. So go ahead, pause the video, and make that happen. Let's see how you did. So here's my math. My x-intercepts drawn right from the equation, change the signs. My symmetry axis, just do my p and my q divided by 2. I get negative 2 for the symmetry axis. Then to get the vertex, I put my negative 2 into my function. It spits out a 2. So my vertex is at minus 2, 2. Finally, put 0 in for x to get my y-intercept. So that's 0 minus 6. So I actually have a full 4 points. We're going to get one more on the graph. So let's go over to that. So check this out. Here's my symmetry axis, my vertex, my x-intercepts, and my y-intercept. I also got this point kind of for free. How did I do that? I reflected this one across the axis of symmetry to get the other one over there. So that gives me a really nicely done drawing of my parabola with 5 labeled points, the axis of symmetry, and it's pretty accurate. Okay, one point that I didn't do in the last example. We were talking about the symmetry axis right there, and how it's basically the average of the x-intercepts, because we just add them up and divide by 2, and that's an average. And that makes sense, because if you come over here to the graph, you'll see that the axis of symmetry is always halfway between the two x-intercepts. It has to be, because it's going down right the middle through the vertex. So if you just take the average of the x-intercepts, you're going to get the axis of symmetry. So that's why that piece looks like it does. All right, to wrap this up, I need to stress that you should be able to do all the things we did in this lesson without your calculator, okay? So when you get to a test, there's going to be a non-calculator version or portion of that test. And questions like this will be there. So make sure you can do that. Now that you've watched the video, take a minute to jot down notes or questions that you might have for our next class. You can also re-watch portions of the video that didn't sink in the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.